Let me demonstrate how I emulated Git on s390 architecture. First, I install a toolchain using the package manager of my distro. I use Arch, by the way, and I found this toolchain that uses glibc. There's also one using Muscle, but I've used the one with glibc. Then if you compile this, you need to tell your build tools that you want to use this toolchain. I use Meson, and Meson has this thing that you can provide a cross file to your Meson setup command. In this cross file, you specify all the binaries of your toolchain. Luckily for me, my toolchain is installed at opt this path, and in etc meson, this file already exists. So I can simply reuse that one. There's one problem though. It uses optimization and it strips the debug symbols. So if I want to debug the process with GDB, I need to change this. I've made a copy of this file over here where I've modified these flags, and now I can compile this with debug symbols. So let me say meson setup crossfile. The crossfile is over here, and I'll be installing it in as s390x. As you can see, this fails because Git needs a few libraries to link against. For example, it depends on zlib, and I don't have that library compiled for this architecture. Luckily for me, Meson has this nice thing where you can say wrap mode force fallback. And here it will download the sources for us and configure them for my target architecture. This will force Meson to compile the sources for me, and it will do that for using the correct toolchain and everything. Now I can compile this. So Meson compile -c s390, and compilation will build everything. So it will build it for this operating system, and all the dependencies are included, and over here it's specified what toolchain to use. So the cross compilation information is read from this file. Now we have Git compiled for s390 architecture. You can check it by checking the file type of this binary. You can see it's built for IBM s390 architecture, which makes it impossible to run this binary on this system because you cannot execute this format. Luckily, there's a tool called QEMU which allows you to emulate other architectures. I've installed the s390 system architecture using also my same package manager. This allows me to say QEMU-390x and say 390x git, but this still doesn't work. So it doesn't seem to find the libraries. To overcome this issue, the solution I have found is specify the library path manually to QEMU. So you can say over here and then sysroot and then say s390x git, and now the git command runs the output that you would expect. Very nice. So we have a running emulation for s390 now. So we can reproduce the issue we have. For example, if we run this against the problem repository and we say git last modified, we're getting this output. This is actually not what we expect. If we would run it with git built for the current architecture, then we get this output. So we can see an obvious difference in output. Now we can start debugging this. Debugging is also very simple. So we can use the QEMU command again, but then we say -g 1 2 3 4. So now we run the command and it waits for a debugger. So in another terminal, we can use GDB remotely. I'm using this command over here, which sets the architecture to s390x. It sets the sysroot. It specifies where the file it is that we're debugging, and it sets a remote target to debug. I'm also setting a breakpoint where I know the issue is. So let's connect here, and then we can say continue. Now we're over here in the source code. Let me enable TUI to make it a little bit more obvious. We can see over here, I know the issues over here. We are at this line. So we can debug as normal. Set bitmap get lm scratch. If I'm getting the first bit, it's 1, and getting the second bit, it's also 1. Now, stepping over this command should set both bits to 0. And that's not the case. So this is where the issue is. It's mem setting with the wrong length. We can fix this by multiplying the length with the size of the E word. So now we can recompile, meson compile, and run QEMU again, attach our debugger again. Yes, continue. So if we now say p bitmap get lm scratch 0, now it's 1, for 1 is also 1, next, they're both being zeroed. So a bug is fixed, and we can disable the breakpoint now, continue, and now the output is correctly what we expect. Let me verify this real quickly. The output is identical. Thanks.